Good morning, students, and welcome to our YouTube channel Eng.Med Model School. So, in today's lecture, we will start with our new chapter, that is lesson number 11, that is pressure. But in the previous lecture, that was crop production and its management, we have seen that how the crops are produced and how its management is done so that we can cultivate or produce more crops. So, okay, in previous lecture we have seen that, and I also in previous lecture I have tell of all the flashback of that chapter. But now we will start our new chapter, that is lesson number 11, pressure. Pressure. So, first of all, what is pressure? We have seen many of the things and doing many of the things in our daily life with pressure. Okay, first let's see an example. If from my hand I push this board and apply pressure, means this will not go back due to it is hard substance. Okay, let's see this book. If this is book, and if I apply a pressure, okay, I apply here in the downside of the book pressure, okay, then this part will go back. So when I apply this pressure on a certain area, that's produce pressure. When I apply a force, if here I apply a force with my hand and at some certain area, then it's called pressure. Then first of all, we write down the definition of pressure. What is pressure? Pressure is defined as unit area, unit per force per unit area, force per unit area. So this is pressure. So let's see first example. If I apply a force in the board, I have applied force from my hand with the board. So on which area I have applied the force? Let me say that. See here, I apply a force in certain area. See here, this is the area where I apply force. This is my hand where I have applied the force. Okay, students. So here I apply the force, but it is hard substance, so it will not go back. As I told about in the book that in the book goes back when I apply the force in some areas. So I have applied the force with my hand in the board in this area. Okay. So let's take a small example of it. See here. Here there is one wooden board. This is one wooden board. Sorry. So this is one wooden board. Okay. This is one wooden board. Here I apply two pins. This is the one pin with sharp nail end. The second one is the this pin, where here it is pin over here and this pin is its opposite side. This pin is like this and this other pin is like opposite side here. So when with a hammer, when I put force, the same force with this pin and the same force with this pin, when I apply a hammer with some force, the same force is put on here and here. So this nail will go inside the board and this will don't go inside the board. Why? Just you imagine that here what is first the force, pressure defined as force per unit area. Okay students, so pressure is equal to force upon area. So this is pressure. Okay students, so when in the board I apply the force with this pin, this has a small area, tip like, but this opposite side pin has big area. Okay students, so here the value of pressure here, what force is same, but here the area is small. The area is small and in this one pressure is equal to force is same, so F, and area is more. Okay students, so what will happen if here area is small, the denominator is more, then the value will get small, means the pressure will be low. But if the area is small and denominator is small, we get pressure high. Okay, we will get pressure more. Okay students, so let me again explain this. Pressure is defined as force per unit area, that is P is equal to F upon A. Okay students, so we have taken an example of, this is a wooden board. Let me draw it again. So this is a wooden board, this is a wooden board. Okay, so in this I have applied two pins, one with like this and another like this. Okay students, so here there is area small, this tip has area small and this one has big area like this. Okay, this has small area here. So here if we draw a tip, so here it is small area, but here it is big area. Okay, so if I apply force same on these two tip, this tip will go inside and this tip will not go inside. Why? Here we take a pressure formula that P is equal to F upon A, and here also P is equal to F upon A, that is force upon area or force per unit area. Here the area force is same in the both options. Okay, force is same, so it will be F only. We take area, means here there is small area, so the value of the area is small, means I do like this, and here the area is more. We all know in maths we have studied that if the denominator has small value, then we get is big, pressure high, and if the denominator has high value, we get pressure low. So this is one of the example. Let's take another example. Another example, it is in your textbook. Here if we take, this is a leg of any man. This is a leg, and here there is a this sandal with some tip which any lady has wear. Okay students, so this is the sandal. If any of this sandal tip is here in our leg, so we hurt. Why? Because here it is small area, this area is small. I have drawn this figure over here, so this area is small. So here the pressure is equal to F upon A. Area is small. As area is small, the pressure will be more. Okay students, and it will hurt our leg. But if this part will be there in our leg, then I will draw this over here, then this part will be in our leg. So here the area is more. This area is more. So we will put this here, pressure is equal to force per area. So here area is less or more students? Here the area is more. As we know in maths, the denominator has more value, the answer will be low. So if the sandals, this part is there in our leg, that will not hurt more. But if this part is there, then it will hurt our leg. Why? I have told you. Let me explain it again. If in our leg, this sandal part, we all know this heighted part, small part is if put in our leg, okay, then it will hurt. Why it will hurt? Because here the area is small. So here from this pressure is applied, force is applied, and here the area is small. So as the denominator will be small, the answer pressure value will be more. So it will hurt our leg. Okay students, and here if this front part will be there in our upon the leg, then what will happen? It has more area. So pressure is equal to F upon A. The force will be same, but the area is more. Here there was small area and here there is big area. So as the denominator value increases, the answer means the pressure decreases. So this will not hurt our leg and this will hurt. Okay, so this is the pressure. Let's see some textual points of it. So now we will see here in your textbook page number, here page number 132. So when we apply a force on an object by pressing it, we say we are applying a pressure on it. The area over which we apply force determines the effect it produces. This leads us to concept of pressure. Pressure is defined as force per unit area. It is physical quantity and can be measured in the SI system of units. The pressure unit of a pressure is Pascal. Means the unit, as we know, for time there is unit called second, minute, hour. Okay, but SI unit is time, means SI unit of time is second, but here the SI unit of the pressure is Pascal. Pascal, which is represented as PA. Okay students, so the Pascal is represented as PA. Now next is, as mentioned earlier, pressure is force per unit area and its SI unit is Pascal. 1 Pascal is defined as the pressure produced when a force of 1 Newton acts on an area of 1 square meter. Putting this in an equation means here 1 Pascal is defined as, let's see that, we all know pressure is equal to force upon area. So 1 Pascal, what is 1 Pascal? When we apply 1 Newton force in 1 meter square area, that produces 1 Pascal. See, in your textbook it is defined as 1 Pascal is defined as the 1 Pascal is defined as the pressure produced when a force of 1 Newton, means 1 Newton is force is applied in area 1 meter square. Putting this in equation, this produces 1 Pascal. Okay, this produces 1 Pascal pressure. Have you ever been accidentally stepped on by someone? Which part of the shoe do you think would hurt more, the flat end or the pointed end? So I have previously drawn here a figure that was leg, here that was leg, and here it is a shoe which has this is shoe with pointed and other shoe which has plain. So the two types of shoe, it is pointed and it has plain surface. From this, which would hurt more? There is a question in your textbook, which of this shoe will hurt more? This shoe has small area, so we will put P is equal to F upon A, that is area is small, here the area is small, the pressure value will be high, so this will hurt more. Why this will not hurt more? Because here it is area big, that is P is equal to F upon A. Area is more, so the value will be low, so this shoe will not hurt us. Okay students, so this is the pressure. Let's see, The pointed end of the high-heeled shoe has a smaller area than flat end and therefore will produce a great pressure. Great pressure produced at the pointed end will hurt more. Means this pointed end will hurt more. Here is an activity, see here in the page number 133, to understand that the pressure depends on the area over which the force is applied. Material needed: a drawing pin and an eraser. Place the eraser on the table top and press it hard as you can with your thumb. As what happens to the eraser? Next, press the eraser with the sharp end of the drawing pin. Means what we have to do is we have to take an eraser and one drawing pin, and in the board first of all put a eraser and press that. It will not go in, but if there is a pin, we will press with our hand of thumb, then it will go, the pin will go, but eraser will not go. So conclusion, we realized from the above activity that the outcome of the force not only depends on the degree of force we apply, but also the area over which we apply it. Means there is area, the tip has small area and the eraser has big area, so the eraser will not go inside and the pin will go inside. Okay students, so you will find that you can make a hole in the eraser very easily with drawing pin, but nothing much happen when you press it with your thumb. In the above activity, suppose we use the same force to press the eraser in both cases. When we press it with our thumb and with the drawing pin, in what way would the two actions differs from each other? The difference is the area over which we apply the force. When we press the eraser with our thumb, we are pressing it over a large area compared to the drawing pin, whose tip has a small area. This outcomes of force is called pressure. Perhaps you may want to see this for yourself by comparing the area of your thumb and the area of the sharp end of the drawing pin. As mentioned earlier, pressure is equal to force in force per unit area. Here is how we can calculate pressure with the help of this equation. Okay students, so this is what is pressure. In the introduction we have seen. Now it's time for your homework. Please note down your homework. So in your homework you have to don't write anything, you have to just read this first topic, that is what is pressure. Read what is pressure. What is pressure? You have to just read up to which I have taught you. Don't read anything else. If you want to read, you can, but you have to read only what is pressure, the whole topic up to which I have taught you. Okay students, up till then stay safe, stay home. Okay, bye students.